So we've completed the four-step hypothesis testing process, and now it's time to write up the results of our research and submit it to a professional journal. There is a standard, almost templated way that we lay out the description and statistical notations when we summarize the results of our research. When we report the results of our research, we don't include the term alpha. Instead, we use the symbol for probability, which stands for the probability of our results occurring in the manner that it occurred. Sample means that fall in the critical region, the shaded areas, have a probability less than the alpha. In this case, null hypothesis should be rejected. Sample means that do not fall in the critical region have a probability greater than alpha. Figure 8.6 on page 219 in your text shows you the relationship between probability and alpha. A special jargon and notational system are used in published reports of hypothesis tests. When you are reading a scientific journal, for example, you typically will not be told explicitly that the researcher evaluated the data using a z-score as a test statistic with an alpha level of 0.05. Nor will you be told that the null hypothesis is rejected. Instead, you will see a statement such as, the treatment with alcohol had a significant effect on the birth weight of newborn rats. Z equals 3.00, P is less than 0.05. In the scientific reports, the researcher does not actually state that the null hypothesis was rejected. Instead, the researcher reports that the effect of the treatment was statistically significant. Likewise, when the null hypothesis is not rejected, one simply states that the treatment effect was not statistically significant or that there was no evidence for a treatment effect. In fact, when you read scientific reports, you will note that the terms null hypothesis and alternative hypothesis are rarely mentioned. Nevertheless, the null and alternative hypotheses are part of the logic of hypothesis testing, even if they are not formally stated in a scientific report. For any test statistic formula, the components of the formula, specifically the value of the numbers for each of the components of the formula, will influence the magnitude of the test statistic that is generated. The most obvious factor influencing the outcome of a hypothesis test, as evidenced by the computation of the test statistic, is the size of the mean difference. The amount of difference between the treated sample mean and the original population mean is the clearest indicator of a significant treatment effect. In Chapter 4, we noted that high variability can make it very difficult to see any clear patterns in the results from a research study. In a z-test statistic, variability is represented by the size of the population standard deviation, and the higher that number is, the higher the variability within the dataset. Higher variability can reduce the chances of finding a significant treatment effect. If other factors are held constant, the larger the variability, the smaller the z-test value will be, and the lower the likelihood of finding a significant treatment effect. The final factor that influences the outcome of a hypothesis test is the number of scores in the sample. In general, increasing the number of scores in the sample will produce a smaller standard error and a larger value for the z-score.